Ms. P, for this section of work today, you're going to be looking at animal behavior, animal defenses, pages 22 to 26. So what are we waiting for? Let's jump in. Chapter 2, entitled Escape Artists. Hiding, standing still, and camouflage help many animals avoid predators. But these defenses do not work all the time. Predators may find hiding places, stumble over prey lying stock still, or discover that a leaf is actually an insect in disguise. Prey animals need a second line of defense. For many animals, this defense is escape. Escape often means fleeing as quickly as possible. Escape also may involve behaviors that buy an animal a few extra seconds to get away. This could be startling a predator or distracting it. Some animals go so far as to actually lose body parts to aid in their escape. A few appear to give up by playing dead. Fleeing. An animal without a burrow or other hiding place can choose between fight and flight. It can stand its ground and face a predator or make a quick getaway. Fighting may be used as a last resort. Fleeing is the first response to danger. Many long-legged, hoofed animals literally run for their lives, relying on sheer speed to escape. Horses, for example, can gallop at speeds of 30 miles per hour or more. Deers race away just as quickly. The pronghorn of western North American grasslands can run about 50 miles per hour. This burst of speed may enable an animal to leave its pursuer in the dust. If the predator persists, however, many hoofed animals can run fast for several miles. A pronghorn can run at 35 miles per hour for about 4 miles. Running works well for speedy four-legged animals. It also serves some two-legged animals as well. The ostrich, the world's largest bird at 8 feet tall, cannot fly. Other than lions and jackals, few animals prey on it. If pursued, an ostrich can outrun and outlaw most predators. It can cruise at speeds up to 40 miles an hour and run at slightly slower speeds for 20 minutes or more. The rhea, a flightless bird of South America, can also run swiftly and turn on a dime. Roadrunners, beep beep, of the southwestern United States deserts can fly, but prefer to run. They can zip along at 18.6 miles an hour. The basilisk lizard normally gets around on 4 legs, but switches to 2 when it's threatened. The lizard lives in trees and rainforests of Central America. When a predator creeps up on it, the basilisk drops out of the tree and lands in the water. Then it rises on its hind leg and runs across the surface of the water. The basilisk dashes about 15 feet in 3 seconds flat before dropping forward to swim with all 4 legs. A kangaroo cannot run, but it can leap away from danger. A red kangaroo can hop at 20 miles an hour for long distances and 30 miles an hour for a short distance. Some people have clocked red kangaroos going even faster. Grasshoppers and crickets leap to safety too. Beach hoppers, which are related to pillbugs, pop into the air by snapping their abdomens and pushing with 4 of their hind legs. Swimming, slithering, climbing, and flying from danger all work just as well as running and jumping. An octopus, for example, escapes predators by filling its body with water, then pushing the water out through a tube-like body part called the siphon. This motion, called jetting, lets an octopus scoot away quickly in any direction. As it jets away, it emits a cloud of ink to hide its escape and further confuse its pursuer. Shellfish, called scallops, also jet away from danger. When a scallop senses that a sea star is near, it opens and shuts its shell, forcing out jets of water that scoot it away. Another ocean creature, the flying fish, escapes predators by swimming quickly just under the water's surface, then streaking up out of the water while stretching out a pair of wing-like fins. It sails through the air for up to 20 seconds before diving back into the water. Some animals roll away from danger. Wheel spiders, which live in Africa and Namibia's desert, start their escape from predatory wasps by running. Then they suddenly fold their legs and flip sideways to roll down sand dunes like wheels. They can roll at a speed of about 3 feet per second. The caterpillar of the moth of pearl moth also goes for a spin to escape by curling into a circle and then pushing off. A species of mantis shrimp found among some Pacific shores rolls up and pushes itself along in a series of backward somersaults. Many predators, however, also have speed on their side. They prey most often using other tactics besides pure speed to make their escape. One way to make a pursuer work harder is to zigzag. A rabbit running from a coyote, for example, does not run endlessly in a straight line. Instead, it dodges back and forth, forcing the coyote to change directions and make sharp turns too. Zigzagging is easier for a rabbit, which is smaller, than for the larger coyote. The coyote also cannot tell when the rabbit will dodge this way or that, so it can't plan its next move. In this way, the rabbit makes the chase more difficult and tiring for the coyote. Though a coyote may still succeed in catching its prey, there is a chance that it may tire out, give up, and go look for an easier meal. Other animals also dart and dash when chased. A herd of impala, slender antelopes of African grasslands, not only run from a predator, but also zigzag in all directions. Impala also leap over each other as they run, sometimes springing as high as 10 feet into the air. This explosion of activity startles and confuses a predator. It also makes it difficult for a predator to chase any one animal. Zigzagging mixed with freezing can confuse predators too. Frogs and grasshoppers will jump in one direction and then freeze, only to pop off in another direction if the predator comes near. A predator may not be able to focus on its prey with all the unexpected starts and stops. Likewise, a cottontail rabbit may go from zigzagging to freezing as it flees. When it runs, it flashes its puffy white tail like a target. When it freezes, it sits on its tail. The predator may lose track of the rabbit because the tail has vanished. And that leads us to the end of chapter 2 for today's work. Go get started with your work.